One, two, one, two, one, two, one, two, one, two. Woo!
Hello guys and welcome back to this one. So now we are going to be jumping straight into the optimized approach. So let's just read my thought notes here. So we said concept is the issue. The concept is the use of two heaps, right? So the concept we are going to be exploring is going to be the use of two heaps and this time around. So one for the right side and the other for the left side. So we are going to have one represent the right hand side of the whole array and one represent the left hand side. It says a max on the left and a mini on the right. So this develops a direct access to the middle value. So we will see that the one generic thing about this solution is the fact that we need to have access to the middle value. Those two, either the odd middle value that just returns a singular middle value, or those two odd guy or those two middle guys that when we have an even middle, right, we need to have access to them as fast as possible. So what this guy did was to use two heaps, and the graphical illustration, my favorite bit, would be the guy to deliver that whole. But before we get to that, let's just look at the code and see what each part of the code means at least. So we say the median online data optimized. So we have a left and a right list. Obviously, we know that at this point that heaps are represented by a list. And we say for data in stream, say invariant one. So basically, we say invariant one. What's an invariant? Invariants are conditions that remain true all throughout the code or all throughout the system. So they can't change. These variables can't. Or will I say values can't change. So that's why we call them invariants. Now I don't have the reason for this one, but I believe we'll see the reason as we read the code. It says if not left or data less than uh, the left value, right, or minus the left value, say heap push bracket, okay, he pushed to the left data minus value into the heap, else he pushed to the right. So this invariant is basically saying uh, the left, or yeah, the left heap, which is going to be a max heap from our illustration, is going to first receive the data, and then after which we then consider the right. Basically that's what it's saying. This is basically saying consider the left value appending to it first before considering the right, and we'll see the reason for that also become alive subsequently. So just to separate concerns, we're just going to focus on the code right now. So it says if not left, basically what it's saying, if the left array is empty, so just go ahead to push into it. But if the data coming in, say at the tip of head, I think I'm not separating concerns, but yeah, this data is saying if the data coming in is less than the value at the tip of, or at the index of O of 1, of O, the index of 0 of the left array is minus, oh, sorry, yeah, is less than minus that value at the tip, then also push into the left array, and then it says else push into the right, to push into the right array, sorry, the right heap. So this left, I would like to break down why we are using minus again. So the reason we use minus for the left heap is because of its a max heap. Just as we've alluded to before, this heap model that we're using here, or the package we're using here, does not release a max heap. It releases a mini heap when working with lists, right? So we now induce a max heap by using minus, which will still come alive when we start to go into the code explanation by using graphical and debugger. So we begin to see what's really going on. But just to stick on business, we go to the second invariant, which says length limits of the right and the left side. So length limits of the left and the right side. So none can be greater than the other by more than one. So we are saying that when we are having these two heaps, so the heap on the left and heap on the right, one thing that must be, a condition that must be static for this situation to remain what do you call it, to be able to solve a median, is the fact that none can be greater than the other one by more than one. So once one heap is greater than the other one by two, then there needs to be an adjustment. So that's what we see here. We say if the length of left and length of length, sorry, I say length of, if length left, that's length of the left and length of the right, is greater than one, then move from the left to the right. Else, and that's because we are pushing to the left first. But then else, if the right is greater than the length of the left by a +1, then move from the right to the left. So basically trying to consolidate and make sure that everything is equal between the two of them as we solve, as we eventually want to solve for the median. Then we go ahead to then, after those two steps, after getting those values, then we locate the left. So you say if the left is equal to the right, what does that mean? If the length of the left and the right of the right is equal, that simply means it's an even list. Boom, we just solve for we just return left tip, return right tip, because obviously we know what a heap does for us. It returns us the maximum value from the list, and this one returns the minimum value from the list, talking about the max heap and the mini heap. So basically when you return those two values, those values represent exactly the middle of our bigger array. Graphical illustration again, we divide that by 2 and boom, we return our median. Now else, if the two of them are not equal and the left is greater than the right, just return the left, because that will be the odd bit that we will be missing. And then else, the right, the same thing, will be the odd bit we're missing if it was greater than the left. And then boom, we return our median. So this is just to give an understanding of what the code is saying, so that maybe variables and write-ups and heap and pop does not throw us off our game. Getting into graphical illustration, we'll begin to see what these solutions mean more in-depthly, how they interact with the system space, and then basically help us bring home the idea of what we are doing. So see you on the next one. Excited about that one. Graphical illustration. Ciao.